Hello, this is a quick review of Learning Target 1.2, which says I can classify real numbers. Big thing is the word classify. We're going to be classifying sets of numbers. Before we start these example problems 1 through 6, I want us to focus on this diagram first. I think this is going to help us understand how to label each. So it says complete the diagram by labeling each set as either rational, irrational, natural, integer, whole, and real. Basically what we're going to be doing, we're going to be talking about the whole set is going to be real numbers. We aren't going to be dealing with any imaginary numbers, so we're only focusing on the real numbers. So that's the whole set. And then to break it down, I want us to start with this small circle right here, and I'm going to write the word natural. Natural numbers consist of the counting numbers, so that would be like 1, 2, 3, so on. And then we move on to whole numbers. Whole numbers now are going to include the natural numbers in the set, but it also is going to add one more number to it. Whole numbers also have the number 0 incorporated with it. So it starts at 0 and then it goes up with the counting numbers 1, 2, 3, ... So it's still the natural numbers, but it also just includes that 0 into it, whole. Now moving on, we have integers. Integers will be our next set of numbers. Integers will be negative numbers. So I'm going to go ... -3, -2, -1, and also the whole and natural numbers. So it's going to be 0, 1, 2, so on, ... Those are integers. Now, there aren't any decimals included in integers. There's no fractions. It's just integers are the natural number or the whole numbers and their opposites. So we have the negatives as well. Moving on our list, then we get into our rational numbers. Now, rational kind of fills in the in-between. It's going to be negative and positive numbers, but this is also going to include decimals. But some important things, the decimals either have to be terminating, so it stops, or repeating, so that if that same number is repeating itself. Some examples would be like -3.5. That is a terminating decimal. It terminates at 0.5. Another example would be like 1/3. 1/3 is also going to equal 0.3 repeating, so that's why it's considered a rational. Also, any like natural number or whole number integer is also going to be considered a rational because you can rewrite, like example 3, you could rewrite that as a fraction 3/1. It's also a terminating decimal. And then we have one more number on our list. This is irrational. Irrationals are going to be decimals that go on and on forever and don't have a pattern. They just go on forever. So some, important ones would be pi is an example of an irrational, or even like the square root of a number that's not a perfect square. So like the square root of 2, the square root of 11, anything like that. And that can be positive or negative. Even like negative pi would be an example of an irrational. Okay, so having that list down, it kind of helps us to answer these problems above. It says classify each number, and then it says our list. So the first one, what I would do, I would try to simplify as much as possible. Pretty much with like this first one, whenever you see the square root of something that's not a perfect square, I know that that's going to be an irrational number. It's going to be a decimal that goes on and on forever. So if we type that in our calculator, we're going to get, it's going to be like -1 minus 3.316624, ... It goes on forever. So just by looking at that, if we were to subtract it, we know that my answer, it's going to be irrational. It's going to be a decimal that goes on forever. So that's number 1. Same thing with number 2. Square root of 56, that's not a perfect square. So because of that, it's going to be irrational. If you figure that out, square root of 56 is going to be like, it's going to be 7.833, ... going on forever. So it doesn't have a pattern. It doesn't repeat, so then it's going to be irrational. Negative 9/5. If we simplify that, we end up getting a negative 1.8. What I want you to notice is that that terminates. So because of that, this is going to be called a rational number. It's not an integer. Now the reason why it's not an integer, I know a lot of people think because of that negative it's going to be an integer, but integers don't have any decimals here. So pay attention to that. Integers don't have any decimals. They do include negatives, but we don't have any decimals. So it's going to be considered a rational. And that's it. Okay, moving on, number 4. Pretty much whenever you see pi with our number, just know it's going to be irrational. It's going to be a decimal that goes on and on forever. If you type that into your calculator, 3 times pi, we get, it's about 21.99114 ... So it goes on forever. So it's just irrational. And that's it. Okay, and then we have the number 0. So if you look back at your list, we have the number 0. Notice how 0 is considered a whole number, but it's not a natural, okay? It's not a natural because 0 is not a part of that list. So it's not going to be considered a natural, but it will be a whole. It is also an integer, and it also is going to be considered a rational number because you could think of that like you could rewrite that as a fraction as 0 over 1, and it still equals 0. It terminates. So it's actually going to have 3 solutions. It will be whole. It will be a whole, an integer, and also a rational number. Okay, we have one more, negative 24. If you look back at your list, negative 24, it's not going to be a natural because it's a negative. It's not going to be a whole number because that starts at 0 and goes up, but it is going to be considered an integer because we have our negative whole numbers here. We have our negative numbers, so it's going to be considered an integer. And then it's also going to be considered a rational number because you could rewrite that as a fraction. You could rewrite this to be negative 24 over 1. That's what rationals are. They're fractions or decimals. So it's also just going to be a terminating decimal, so that's why it's going to be considered rational. Okay, so that was a very quick overview of classifying real numbers. Let me know if you need help.